Okay, so now we're going to go through factor analysis. So now, of course, the first question that should come to a person's mind would concern, what is factor analysis? Excuse me. I'll just say, please excuse me if I clear my throat here because I've got a bit of my throat's kind of clogged up. Okay, so like we were saying, the question should arise, what is factor analysis? So now, factor analysis, according to Palant, it concerns, it is a data reduction technique. Factor analysis is a data reduction technique that takes a large set of variables. So there we've got another key term, large set of variables, and allows that large set of variables to be reduced to a smaller set of factors. So therefore, technically speaking, factor analysis is a method to apply a funnel effect to a large set of data. So if we think about it, we take a large set of variables and then we basically reduce them down to a smaller set of factors. So now what is meant, what exactly is referred to by the term factors, okay? Now we noticed in Palant's book that two different meanings can be attached to the term factor, and it varies between factor analysis and analysis of variance. So like we phrase it here, take note, the meaning that is attached to factor varies between factor analysis and analysis of variance. And analysis of variance is also referred to as ANOVA. So now in factor analysis, the word factor refers to a group or clump of variables that are related to each other based on their intercorrelations. Okay. Now in the case of analysis of variance techniques, in the case of analysis of variance techniques, factor refers to the independent variable. But we'll get to ANOVA later, so don't worry about that for now. But, okay, factor analysis uses the word factor to refer to a group or clump of variables that are related to each other based on the intercorrelations. So therefore, in the case of factor analysis, once we've used intercorrelations among the variables, all of those that group together form a cluster, and now that cluster will fall under a common theme, a theme that is common among all of those variables. Now, in the case of a questionnaire, those variables will concern items, the questions that are asked. So therefore, when we are evaluating a questionnaire, factor refers to a clump of items. So in this case, I'll say okay, so in the case of factor analysis, factor refers to a clump of variables or items, or in other words, the questions in a questionnaire that are related to each other based on the intercorrelation. So when we're evaluating a questionnaire, the word factor refers to a bunch of questions or items, same thing, that all relate to each other, and therefore they fall under a common theme that is being measured. So in other words, all of the items that form a factor based on intercorrelations measure a common theme, okay? So now it says here, factor analysis is used extensively in the development and validation of scales. And now a scale is another word for questionnaire, okay? So like we said, factor analysis is used extensively in the development and validation of scales. The scale developer starts with a large number of individual scale items, and scale items refer to the questions that are asked in the questionnaire. And then by using factor analysis, the researcher will refine and reduce those items, those items to form a smaller number of coherent subscales. So let's read through that again. In a case of scale development and validation, the scale developer will start with a large number of individual scale items, and then by using factor analysis. Okay, and then by using factor analysis, the researcher will refine and reduce those items to form a smaller number of coherent subscales. So therefore, we take all of the items / questions that are asked in the questionnaire, we use factor analysis, we enter the data, and then we see which items form clusters, okay? And then all of those clusters that are formed will basically, all of the items within a cluster fall under a particular theme, and that theme will therefore be measured in the questionnaire via those items. So now they say the common theme among the intercorrelated items will determine the name / title of that factor, okay? So now there are two approaches to factor analysis. The first concerns exploratory factor analysis, and the second concerns confirmatory factor analysis. So now, what does exploratory mean? When you explore something, you don't really know much about it, so therefore you're going to see what you can find. If you don't know anything about a particular topic, you won't have any presumption. So therefore, in exploratory factor analysis, the researcher won't have any presumptions about the factors that are formed via the intercorrelation of the items and the subscales that they compile. Okay, now subscales, we're talking about the smaller scales within the greater overall scale. Okay, so then in terms of confirmatory factor analysis, what we would do is we confirm or test a hypothesized model or theory about the underlying structure of the relationship among the variables of interest. Okay, so now what does this mean? Confirm, in other words, we have a presumption. They say there's a hypothesized model or theory about the underlying structure of the relationship among the variables of interest. So in the case of a questionnaire, we have the presumption that, okay, this questionnaire measures these dimensions or factors, and then because I believe factor and dimension are synonyms in the case of factor analysis, excuse me. So then we assume, okay, let's say we assume 8 items under, or 8 items within the scale measure factor 1, 10 items within the scale measure factor 2, 4 items within the scale measure factor 3. So we have these presumptions about the amount of items that measure each factor, and then via factor analysis, we're going to evaluate the loadings to see how many items load onto each factor, and we will also want to see if there are any double loadings. So for example, that would be a case of confirmatory factor analysis. So now we get to interpreting factor analysis. Okay, so the first step, we want to look at the scales that we use to measure the dimensions of factors. We want to make sure that they're reliable or internally consistent. So therefore, number one, certify the reliability / internal consistency of the scales. In other words, the questions. Let me just quickly put that down to questions that were used to measure the dimensions / factors. Let me just make sure. Now we can say questionnaires because questionnaires consist of all of the questions in it. Okay, so now I presume with some of you, when you see this phrase about certify the reliability or internal consistency of the scales, and then you see words such as alpha coefficients, I don't know, I presume some of you might be kind of like worried right now, but don't worry, you'll see it's not difficult. Over here it says look at the alpha coefficients, okay? So therefore keyword alpha coefficients, okay? A scale will only count as reliable if it yields an alpha coefficient that is equal to or greater than 0.7, okay? So let's look at an example. Okay, so over here, let's go to this article by Rothman, Mostert, and Stradom. So what I'm going to do now is I'm going to search for, okay, the keywords I believe a person can look for are either alpha coefficient or reliability. Okay, so what I did to get that search bar up there is I pressed Control and F. If anyone is wondering about how I managed to do that. Okay, so now let's look over there. Statistical analysis. They say that Cronbach alpha coefficients were calculated to assess the reliability. So here under statistical analysis, they're just describing the methods that they're going to use to evaluate the scale. So then, okay, over there under descriptive statistics, alpha coefficients and correlations, it says table 5 shows that highly acceptable alpha coefficients ranging from 0.76 to 0.92 were obtained. So let's see, where's table 5? Okay, table 2, let's go down. Okay, so there you see the keyword alpha coefficients. Okay, so let's zoom in over here. Okay, alpha coefficients. So therefore, these are the dimensions that are measured by each of the scales. We can see this alpha sign over there. Well, that alpha sign refers to the alpha coefficient, and the alpha coefficient over here we said must be equal to or greater than 0.7. So it's phrased as therefore if the alpha coefficient of a scale is equal to or greater than 0.7, the scale is reliable. So we can see over here all of these alpha coefficients are equal to or they are greater than, they meet the bare minimum of 0.7 as an alpha coefficient. So therefore the keywords we're looking for, would you want to find out about the reliability or internal consistency, and I believe reliability and internal consistency are synonyms. So like I was saying, when we want to search for and validate the reliability or internal consistency of a scale, we want to look at the Cronbach alpha coefficient. So now, of course, that wasn't difficult. Hey? Okay, so like I say, don't worry when you see all these fancy scientific words, okay? So we just validated the reliability of a scale using the Cronbach alpha coefficient. Okay, so now don't worry about that table. Okay, so going to factor analysis, let's see. Okay, so then we say we want to look at the eigenvalues. Okay, now in terms of factor analysis, only factors that have an eigenvalue that is equal to or greater than 1 can be extracted and included in the final questionnaire. Okay, the eigenvalue of a factor will represent the amount of the total variance that can be explained by that factor. Okay, let me just, sorry, I'll just edit this. Beg your pardon. Okay, so now let's look over here for eigenvalue. What did we say the eigenvalue does? The eigenvalue of a factor will represent the total amount. Sorry, excuse me, I lost my train of thought. Okay, the eigenvalue of a factor will represent the amount of the total variance that can be explained by that factor. Okay, therefore, when observing the eigenvalue of factors that were extracted, the percentage that is mentioned next to the value of the factor or dimension, next to the eigenvalue of the factor or dimension, will indicate the percentage of variance in the outcome or dependent variable that can be explained by the dimension. So over here, let's look for eigenvalue. I made a note over there. I've noticed that the eigenvalue is also usually mentioned under results or results in discussion or at the bottom of a factor analysis table. Now, by the way, this is a factor analysis table. The minute you see factor 1, 2, 3, 4, 5, however many factors they're measuring, and you see all of these numbers in rows like this, you know that's a factor analysis table. Okay, so let's go down to results. Okay, so in this case, results and discussion are two separate sections. Okay, there we go, results. Okay, so let's look for the eigenvalues over here. Where do they mention eigenvalues? Okay, let's just take the shortcut. Unfortunately, this will not be possible. We won't be able to use the control find function with a piece of paper, but like we know, it will be mentioned under the results section, and in some cases, this section is phrased as results in discussion, or another place where we can find the eigenvalue is at the bottom of a factor analysis table. Okay, so in this case, they discuss an analysis of the eigenvalues showed that 9 factors would be extracted. So therefore, 9 factors had eigenvalues that were equal to or greater than 1. So over here we see okay. Okay, so let's read what they say over here. Okay. An analysis of the eigenvalues showed that 9 factors should be extracted. So therefore, 9 of the eigenvalues nine of the eigenvalues were equal to or greater than 1. Okay. However, the scree plot showed that 5 factors would be extracted, which explained 0.81% of the total variance. Okay, so I don't know about if they're going to ask us to look at the scree plot in an article. I've never seen an author mention a scree plot in an article, but just so that you're not confused or left hanging. I remember we went through the scree plot method at the beginning of the year. Now, according to the scree plot method, we look at the line over here, and then we look at where the line starts to flatten. So, for example, it starts to flatten over there. And then we look at the facts that are above the so-called elbow of the line graph. Now, the elbow I'm referring to where the line starts to flatten. So, for example, this would be the so-called elbow, and 2 factors are above it. So that would be in this case. This is not the actual scree plot that they used, but it's to explain the concept of the scree plot. So let's look at this example of a scree plot. Where does it start to flatten? I'd say it starts to flatten about over there. So therefore, 2 factors are above the elbow of the graph where it starts to flatten. Therefore, according to the scree plot method, 2 factors will be extracted. So now in the case of this article, they say that the scree plot showed that 5 factors could be extracted. So let's read from the beginning again. Okay. An analysis of the eigenvalues showed that 9 factors could be extracted. However, the scree plot showed that 5 factors could be extracted, which explained 49.81% of the total variance. So therefore, out of all of those eigenvalues that were above 1, there was a case where all of them were plus minus around the same value, and we want to extract the minimum amount of factors in factor analysis. So they double checked by looking at the scree plot method, and according to the scree plot method, the elbow of the graph basically started to, the elbow of the graph was below 5 factors. So therefore, let's picture it, let's try to, I'll quickly just search for paint so that I can, okay, paint. So now, if I want to picture this visually, okay, they say that initially the eigenvalues stated that 9 factors should be extracted. Okay, so therefore, brush, let's see that. Okay, so now these are our lines, and I haven't seen the scree plot, so I'm trying to do this as well as possible. 3, 4, let's say 5, and then from there it started to flatten. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so if this was on a graph over here, excuse me, that's not a very straight line, but you get the point. If this was on a graph, we can see over here it starts to flatten. So it's basically started to flatten over there. So now, how many factors are above the line? 1, 2, 3, 4, 5. Okay, so therefore these factors explain the most variance, because we can see over here the whole point is where it starts to flatten, there's not much of a variance between these, so therefore we exclude those. But this is what they mean when they say that according to the scree plot method, 5 factors were extracted. Okay, so in any case, if we go back to the stage we're at, we look at the eigenvalues. Okay, so now in terms of eigenvalues, we only want to extract those that are above 1, but these people recommended, okay, scree plot method, so let's take 5 out of it. But I think the main thing that Crizal will want us to know, she wants us to know, okay, what does the eigenvalue indicate? Now, according to the eigenvalue, okay, the eigenvalue indicates the amount of variance in the outcome variable that can be explained by the factors. Here, the authors say that 49.81% of the variance was explained by by only 5 factors. So therefore, the most variance at the minimum amount of variables amounted to a case where 5 factors were extracted, and those 5 factors explained 49.81%. And this 49.81% would have been calculated by taking the eigen, there'll be a thing that mentions the amount of variance that is explained by each factor that is extracted, and then they add the percentage of variance together, and they got 49.81%. Okay, so let's look for another example of an eigenvalue. Okay, let's look eigenvalue. Let's see what they said over here. Here they're just indicating that they use the eigenvalue as a method. So let's see over here under results again. Okay, eigenvalues, a simple principal component analysis. Okay, you don't have to worry about that. That's just fancy talk. Then they say an analysis of the eigenvalues and a scree plot indicated that 7 factors would be extracted. But over here, I notice they don't mention the eigenvalues or the percentage of variance that is explained. So let's see if this example mentions an eigenvalue. Okay, so therefore, they say the first factor had an eigenvalue of 5.39, so this is above 1, and it explained 25.67 of the variance. Okay, the second factor had an eigenvalue of 2.99 and explained 14.26%. So as we can see over here, they are indicating the amount of variance in the dependent variable that was explained by each of the factors that were extracted. And then if we add the variance of each factor together, it'll basically give us the overall percentage of variance in the dependent variable that can be explained by the factors that were extracted. Okay, so let's say in this case, how many factors were extracted? Okay, well, I only see 4. If I missed any, please forgive me. Okay, so let's say 4 factors were extracted, and now the title of the questionnaire that they are placed in, that is the outcome variable that the questionnaire measures. And now let's say the variance that each of these eigenvalues measure. Okay, let me just rephrase that. The amount of variance in the dependent variable that is measured by each factor, which is indicated over here by the percentage. If we add all of those percentages together, that will tell us the total variance or the total percentage of variance in the dependent variable that is measured by the questionnaire in which these factors are placed. Okay, so that's the eigenvalue. So, for example, let's look at the type of question Chrysalis knew there was something about the eigenvalue. What is the eigenvalue? So we just saw the eigenvalue is a statistic that is used in factor analysis that indicates the amount, it indicates the amount of variance of the dependent variable that is explained by the particular factor. But another thing that we must mention over here is that the eigenvalues also indicate the factors that must be extracted to measure our dependent outcome variable. Also indicate the factors that must be extracted that's the eigenvalues, okay? I mean, that they will cover the topic of eigenvalues. I hope that I haven't confused anyone. So like we've said over here, luckily, if you need to revise the information, this is a video, so you can rewind it and go over it again, okay? So now, like we said, the eigenvalues are noticed that they're cited in the following locations in an article, either under results, which can also be phrased as results and discussion, or under a factor analysis table. Let me look for the example in which the eigenvalues were cited under the table. I think it might be this one. Oh, yes, over there we can see now this is a factor analysis table. How do we know? Because factor 1, 2, 3, and we've got all these numbers over here. Main thing, factor 1, 2, 3, 4. Okay. Now over there they show the eigenvalue. Here they show that this eigenvalue alone explains 40% of the variance in the outcome variable. And now over here, the outcome variable, the dependent variable, concerns weekly job resources. So the first factor explains 40% of the variance in weekly job resources. The second explains 54%. This is cumulative, cumulative percentage of variance that is explained. So therefore, factor 1 alone explains 40%. Factor 1 and 2 together explain 54% of the variance in weekly job resources, and factor 2 added 14% to the explained variance, and so the pattern goes on in these two cases. Okay, so therefore factor 1, 2, and 3 together explain 64% of the variance in the outcome variable, and factor 3 added 10% to the overall cumulative percentage of explained variance. And yeah, so the pattern goes on. So I don't want to spend too much time explaining, like, because I believe that you got the concept over there, but I just mean, like, I don't want to record a ridiculously long video. Okay, so now let's look at what we've done. We certified the reliability and internal consistency of the scales that were used to measure the dimensions of factors. We looked at the eigenvalues, so in other words, we looked at the percentage of variance in the dependent variable that can be explained by the questionnaire and its factors. Okay, so then we go on to identify the topics or themes that are being measured by means of the factors that are involved in the questionnaire or the scale. Okay, because we want to know what each factor refers to. Factor 1, factor 2, like what are they talking about? Okay, so look over here. Okay, so now I've noticed two methods that a person, when you read in an article, two methods that one can use to identify the factors, the themes that are being referred to by each of these factors. So now, in the case of Rothman, I cite over here this article, I noticed that the factor headings, okay, let's just read this first. Search under the results for the themes that are measured by each of the factors, okay? So let's go to results. Okay, here we can see factor 1 was labeled as growth opportunities. Okay, factor 2 was labeled as organizational support. Factor 3 was labeled as advancement. And factor 4 was labeled as overload. Look over there, factor 4 was labeled as overload. Factor 5 was labeled as job insecurity. Okay, so therefore, let's take a look. The items that load significantly under factor 4 measure overload. Okay, so let's see how we phrased it in the notes over here. Search under the results for the themes that are measured by each of the factors. Look at the factor headings of the factor analysis table and then link those factor headings to the labels that are attached to them under the results paragraph of each article. So for example, okay, there's factor 5 under results. What does it say factor 5 refers to? There they say factor 5 refers to job insecurity. So we know, like I said, all of the items that load significantly onto factor 4, for example, measure, what was it again? Overload. Okay, so now we know what our scale is measuring. Okay, so then in the second method, I noticed that some authors, let's just read how, as I phrased it over here. Okay, another method that researchers use to indicate the factors or dimensions that are being studied includes placing the name of the dimension above the items in the left-hand side column of the factor analysis table. Okay, so I said over there Bakker and Bol. Okay. Okay, so over here, how do we know this is a factor analysis table? We see factor 1, 2, 3, and 4, and it's not a definite number. It can be up until factor 6, but the whole point is we see factor and a number. But there are cases where an author does not use that method to indicate. So for example, here, they just said exhaustion. Let's double check. EX refers to exhaustion, DE refers to disengagement. Okay, so over here, they did not label them as factor 1, 2, 3, and 4. They went straight to labeling the dimension that's being measured. But once again, we've noticed a pattern of loadings in lines, okay? So that's the main identification means of a factor analysis table, I believe, is that we look for, trying to think, items or questions on the left-hand side, and then we look at a pattern of numbers that are vertically arranged. Okay, so now getting back to the topic of identifying the themes that are being measured by the factors. Okay, the second method, we said another method that researchers use to indicate the factors or dimensions that are being studied includes placing the name of the dimension above the items in the left-hand side column of the factor analysis. Okay, so over here, this is the item or the question, and we see these are placed underneath autonomy. So therefore, all of the, let's say the factor upon which these items load significantly, that factor measures autonomy. Okay, so therefore factor 3 is autonomy. Okay, let's look at these questions. Okay, they load significantly on factor 4. So therefore factor 4 concerns social support. Okay, so let's look at under exchange with supervisor feedback. Okay, these items load significantly onto factor 1. So therefore factor 1 concerns exchange with supervisor in terms of feedback. Okay, so therefore we've identified methods to recognize and identify the factors, should I say the themes or dimensions that are being measured in the factor analysis. Or yes, I just hope I'm not mixing my words up right now. Okay, just excuse me if that's the case. Let me just go through that again. Okay, we have identified methods via which we can recognize the themes that are being measured in the questionnaire. Okay, and these are referred to in this factor analysis table as factor 1, 2, 3, and 4. And like I say, I've mentioned ways to link the factors with the themes that they refer to. Okay, so now in the factor analysis table, we're aware that it is reliable, we're aware of the amount of variance in the dependent variable that it explains, and we are aware of the themes by which the dependent variable is measured. Okay, so now we want to look at I'd rather say items. So now we want to look at the amount of items that can be extracted from the scale that is being analyzed to be included or put into the final scale. So the way that we do that is look for the factor analysis table. Okay. pardon if I'm like hurting anyone's eyes. Trying to see. Okay, let's just look for the other example I want to go through. Okay, so this is the example we're looking for. Okay, so now we're going to highlight all of the items with a value equal to or higher than the minimum loading. So now these numbers refer to the factor loading of each item. So the item refers to the question, and now these values indicate onto which factor this question loads. So in other words, which factor does this question measure? So over there it's 0.65 on factor 4, and let's say that the minimum loading is 0.3, that is above 0.3, so it loads onto factor 4, and factor 4 refers to overload. So therefore, this question, the first question, do you have too much work to do? This question measures overload. Okay, so that's the way to interpret it. Okay, so what we want to do now is we want to highlight all of the values with a loading, or a factor loading that is equal to or above the prescribed minimum loading. So here we phrased it as, go to the factor analysis table and highlight all of the items with a value that is equal to or above the prescribed minimum loading. So the comments we said here, or made here, are the following: highlight all of the items that have a factor loading that is equal to or greater than 0.3. Such items are suitable to be extracted and placed in the final questionnaire. Okay, so now this Tabak, Nick, and Fidel, they were cited in Palant, and Palant said that the minimum factor loading is 0.3. But then we go on to state, however, rather ask your assessor about the cutoff point that they prescribe to the factor loading, and then highlight the variables accordingly. Because if I remember correctly, Crizal suggested that factor loading should be 0.4. So, and at the same time, other authors say 0.3. So, yeah, the problem, yeah, like I said, it varies between authors. So therefore, ask the assessor about what the minimum factor loading is. So, okay, let's say in this case, we go with the suggestion, the first suggestion of a factor loading of 0.3. Okay, let's look at our factor analysis table. These numbers, okay, this is above 0.3, that is above 0.3, so we're going to highlight all of the factor loadings above 0.3. And I know in some cases also with statistical analysis, we should look at the factor loading. Okay, here they say a cutoff point of 0.30 was set for the practical significance of correlation coefficients. And now that is just another word for the factor loadings, because these use correlation coefficients. Remember we said the intercorrelations are concerned in factor analysis. So therefore, in this case, the author said the cutoff point is 0.3. And over there, we looked underneath statistical analysis. Okay. So now let's go down. Okay. 0.3, it's above 0.3. Okay, it's also above 0.3. Excuse me if I miss any of the factor loadings that are above 0.3. Okay, 0.29 could be rounded off to 0.3. So what we're doing, looking for all of the factor loadings equal to or greater than 0.3. And we're highlighting them so that we can easily identify them when we analyze the case of this factor analysis. Okay. Okay, so therefore we've highlighted all of the variables that have factor loadings equal to or greater than 0.3. Okay, so let's see what we say. What must we do next? Okay, so then what we do, let's just see the comments I made over here. Okay, this I should rather have stated it over here. Very quickly moving that to avoid confusion. Okay, so now we have highlighted all of the items with a value that is equal to or greater than the prescribed minimum loading. Okay. So now we look for double loadings because it says if an item yields a significant loading under more than one factor, the item will not be extracted to be included in the final questionnaire. Because let's look, okay, for example, a case here of a double loading. Okay, this question, does your job offer you opportunities for personal growth and development? Now this loads significantly on both factor 2 and factor 3. So let's see what factor 2 and factor 3 refer to. Factor 2 concerns organizational support and factor 3 concerns advancement. Okay. So therefore, does your job offer you the possibility of independent thought and action? So in this case, it looks like the respondents associated this question with both organizational support and opportunities for advancement. So let me quickly look if sorry, I beg your pardon, that was this question. Does your job offer you opportunities for personal growth and development? So that loads significantly onto both factor 2 and 3. Now we saw factor 2 refers to organizational support and factor 3 refers to advancement. So therefore, it looks like there's a bit of ambiguity about what is meant by this question since respondents associated the question with both of these dimensions. So therefore, because of that ambiguity, we're not going to include this question in the final questionnaire, or we should rephrase the question and reevaluate it. So that case will apply in all of the different cases of double loadings. As you can see, there's another double loading, another 3, 4, 5 double loadings. Okay, so there are another 2 double loadings. Okay. So now we've seen the double loadings, we've identified questions that thus far we cannot really rely on them because they do not seem to be clear. So then after we've identified questions that must be removed from the questionnaire, we want to see the amounts that will still measure our dimensions, okay? Those that can be relied on to adequately measure our dimensions. So for example, let's say I'm only going to leave the items that can be relied on to measure a particular factor. I'm only going to leave those highlighted, so therefore I'm removing the the highlighting of the double loadings, and you'll see the point of that now. Okay. Okay, so let's just go according to the first few dimensions. So then, according to Palant, only 3 or at least 3 items must load onto a factor in order for the factor to be included in the final questionnaire. Okay? This is just another way of saying that. Okay. So now in the case of the fourth factor, okay, more than 3 items load onto that factor, so we can include that factor in our final questionnaire because it will be measured adequately. Okay, in the case of the second factor, if we remove the double loadings, we've still got at least 3 factors, at least 3 items that will measure the factor. Okay, the same applies in the case of the first factor. If we remove the double loadings, we've still got at least 3 items that will be able to measure the factor. So yeah, and then therefore, let's say we have a factor that does not meet the bare minimum of having 3 items that measure. That factor will not be involved or included in the final questionnaire. Okay, so that is factor analysis while we use it to evaluate a questionnaire. Okay, and then just trying to think about if I should go through another example. But I believe the point comes across. If you would like me to go through another example, please let me know. But the thing is, I'll be honest, I can't promise that I will be able to. But like I said, I can't give my word about it. But I will if I can. But I hope that this has allowed you to grasp the concept of factor analysis. Let's cancel this. Okay. Yeah, but like I say, good luck. Yeah, good luck for the exams, and keep pushing.